In example 1 for 10.3 gives us some nice concrete examples of function composition, but they get us to evaluate an actual value of x. And much like if you remember back to usually in grade 8, grade 9, we teach you how to deal with brackets within brackets, you were probably taught, I hope, that you should deal with the innermost bracket first and then go from there. And it's the same thing with function composition, but I'm just going to change that definition a little bit, and I'm going to say that you should deal with the innermost function first and then the outermost function after. So when we look at A, which is function f evaluated at function g evaluated at 3, which is a mouthful. Sometimes English and math don't go together that well. We have an inner function. We have function g, and it wants us to find g of 3. So g of 3, and I'm going to use function g, which is given to us right here. G of 3 would be equal to 3 plus 6, because I replaced the input with 3, and I get that g of 3, therefore, is equal to 9. Now, this is an important statement. It means that the expression g of 3 can be replaced by the value 9, which we are going to exploit, to say that f of g of 3 is really function f evaluated at 9, because that's what g of 3 is. And function f evaluated at 9, function f is 4 times x. So function f evaluated at 9 is going to be 4 times 9, or 36. Now, we have gone a little bit down the rabbit hole and talked about a lot of equalities, but what we can summarize this is function f evaluated at function g evaluated at 3 is equal to the number 36. When you are working with this, it is very important that you can get lost a little bit in the complexities of these functions. Take it piece by piece and deal with the innermost function first. All right, so B wants us to do just another function composition, but they want us to do function g evaluated at function h, which has been evaluated at -2. So we're going to do the inner function first. So function h evaluated at -2. I am going to take h of x, which is given to me up here as h of x is equal to x squared, and I'm going to substitute -2 in for x. That bracket is a lifesaver because h at -2 is +4, not -4. Which means I can rewrite g at h of -2 as g evaluated at 4, and g evaluated at 4 is going to be 4 plus 6, which is to say 10. Now, I really do think as we work through these, it's important to summarize a little bit, and I'm going to say that function g evaluated at function h evaluated at -2 is equal to 10. This is that kind of final statement that we're looking for. That's really, if it was multiple choice, that would be your answer. They would just have maybe 4 numerical values to choose from. All right, this last one confuses students because it's the same function, and it wants us, I'll write it down here, to find h evaluated at 2. All right, we are not going to do anything different. We're going to find h of 2 first, which is 2 squared. So h of 2 is going to be equal to 4. That means that I can rewrite this as h evaluated at 4, and h evaluated at 4 is 4 squared, which is 16. So I could say that function h evaluated at function h of 2 is equal to 16. This can seem very confusing at first glance. Please make sure you are taking this in small incremental steps and working through the homework, because it will make a difference and it will help quite a bit. The other thing that I'd like to point out too is that if we're given a graph of function f or function g, this g of 3 is equal to 9 literally means the coordinate 3, 9 is on the graph of function g. And you'll see that in a couple questions in the textbook.